Good morning, guys. Today we are going to talk about Chapter 7, which is probability. So we're going to go over some notes and then we're going to do some examples. So probability. In elementary, you probably learned some basic knowledge that should carry over. Probability is the measure of how likely an event is to occur. Okay? So say we have a six-sided number cube, okay? So a six-sided number cube. Okay, so six sides, they are numbered 1, 2, 3, 4, 5, 6. So what would be the probability that I roll a number 7? Well, I can't because there's only 6 options. So that would be impossible. So when we put it in terms of this, it would be represented as 0. It cannot happen, okay? So what is my probability of rolling less than 7? Well, they're all less than 7, correct? 1, 2, 3, 4, 5, 6. So that is certainty, okay? It will happen for sure, 100%. Now, what's the probability of rolling an odd number? So I have 1, 2, 3, 4, 5, 6. What are my odd numbers? I have 1, 3, 5. So my probability would be 3 out of 6 gives me 1/2. Okay? So, impossible, as likely as not. It could go either way. Or 100%, we have certainty it will happen. We write our probability as the probability of an event happening, okay? And that is the number of favorable outcomes over the number of possible outcomes. So the example here for rolling an odd, I had 1, 2, 3. I had 3 odd. That's what I want to roll. And I have 6 options. Well, if I reduce that, I get 1/2, which we already decided was 1/2 up here. Okay? There are 2 types of theories. We have the theoretical and the experimental. All right, so let's start with our first example. Let's move this out of the way. Our first example is right here. Okay, let me zoom in a little bit. All right, so the fundamental counting principle. Well, I guess we should go and let's get this written first. What is the fundamental counting principle? All right, so our fundamental counting principle is used to find the number of possible combinations of a group of objects. Okay, so our fundamental counting principle helps us to find the possible combinations. So on our first example, we're going to use the fundamental counting principle. All right, let's go back in. All right, so for the lunch special, you can choose an entree, a drink, and a side dish. How many meal choices are there? Okay, so here is our menu. We can choose an entree, we can choose a side, and we can choose a drink. So you could have made a tree diagram or even a list. So if I were to make a list, I would say, okay, I can choose pizza with coleslaw and milk. Okay, I could choose pizza, coleslaw, and juice. Okay, on and on and on to make my list. That would take a very long time. So we are going to use our fundamental counting principle to be more efficient. Okay, so what our fundamental counting principle lets us do is we multiply all of our options together. So we have 3 options. Okay, entree, side, drink. And we are going to multiply. How many entrees do we have? We have pizza, chicken, beef. We have 3. How many sides do we have? We have coleslaw, salad, fruit. We have 3. How many drinks do we have? Milk, punch, juice, iced tea. We have 4. So if I were to use my calculator, and I want you guys to use your calculator, 3 times 3 is 9. 9 times 4 is 36. So there are 36 possible outcomes. Okay. For our second example, let's look at another one. All right. We are going to say, let's see, let me get this all in here. Okay. In Utah, a license plate consists of 3 digits followed by 3 letters. So right off the bat, I would just kind of set it up. Okay, so the license plate has 3 digits. So all of these are digits. Followed by 3 letters. So 1, 2, 3. These are letters. And I know I'm going to be multiplying them all together. Okay, the letters I, O, and Q are not used, and each digit or letter may be used more than once. All right, so for digits, okay, think about a lock combination. What are all of the different digits you can on your little lock on your locker? Okay, so you have 0 to 9. How many digits is that? I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, but I count 0, so there are 10 digits possible. So in all of these, because they said a digit or letter may be used more than once, these are all 10 digits. Letters. So you would normally say, okay, well, there are 26 letters in my alphabet. But I cannot use I, O, or Q. So I'm taking 3 away. So my letter options are going to be 23, 23, and 23. Okay, so use your calculator. You are going to do 10 times 10 times 10 times 23 times 23 times 23. And our answer we're going to get is 12,167,000. Okay, so we are multiplying all of our combinations together. All right, let's look at my next example. All right. A make your own adventure story lets you choose 6 starting points, gives 4 plot choices, and then 5 possible endings. How many adventures are there? All right, so let's set it up. Starting points. Plot choices. Endings. Okay, so how many starting points did they say? 6. How many plot choices? 4. How many endings? 5. So if you put that in your calculator, you have 6 times 4 times 5. You should get 120. Our next example. Let's zoom out a little bit so we can get it all. Okay, so a password is 4 letters followed by 1 digit. So right away, 4 letters, 1 digit. And you just put your multiplication sign in between. All right, uppercase letters A and lowercase letters, little a, may be used and are considered different. So remember, there are 26 letters in the alphabet. If I use 26 uppercase, I can use 26 lowercase, and I get 52 letters that I'm able to use. So the first 4 are letters. So I'm going to do 52, 52, 52, 52. And the last one is a digit. Okay, again, digits are 0 through 9, and there are 10 of them. So use your calculator, and we are going to get 73,116,160. Okay. All right, let's go back to our notes. All right, let's see. We're going to talk about permutations. Okay, this was an example, and I've already sent you guys the pictures of the foldable. This was our entree, side, and drink. But now I want to talk about permutations. Okay, so permutations is the selection of a group of objects in which order is important. Okay, so we're going to get into combinations tomorrow, but today permutations, the order is important. I need you to remember that, because when we read these, we need to make sure that, yes, order matters. Okay, so first we have to discuss this factorial. Okay, so this is read as n factorial. And it just means n times n minus 1 times n minus 2. Let's just look at numbers. 7 factorial would be 7 times every number under it. So 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you put that in your calculator just like that, 7 times 6 times 5 times 4 times 3 times 2 times 1, we get 5,040. Okay? So with the permutation, we write it just like this, okay? Our n represents all of our choices, and our r represents what we want, okay? So n factorial over n minus r factorial. All right, so let's look at an example, and hopefully it will start to make sense. Okay, permutations we're getting into now. All right, how many ways can a club select a president, a vice president, and a secretary from a group of 5 people? So if I were to write my permutations, we have n and r. Remember, n is the total amount. So when I read this, how many total people are there? There are 5. So my n is 5. How many am I choosing? I'm choosing a president, a vice, and a secretary, so that's 3. So I'm going to write my permutation just like this. Now what this means is your permutation is your n factorial over n minus r factorial. So if I plug in my n and r's, I get 5 factorial over 5 minus 3 factorial. And that is 5 factorial over 2 factorial. So if I were to write this out, this is what this looks like. This would be 5 times 4 times 3 times 2 times 1 over 2 times 1. Now 2 divided by 2 is 1, so they cancel each other out. 1 divided by 1 is 1, so those are canceled out. So I'm left with 5 times 4 times 3, and you get 60. Now I'm going to show you on a calculator. You can do this on your calculator. All right, so let me put my calculator here so we can see. We are doing 5 factorial over 2 factorial. Now, if you look, this is the TI-30XA at the number 9. Let's zoom in and see if you can see that a little better. Okay, we see a permutation. You see the P with a little n and a little r? Okay, so if I were to do this, I'm going to look at my permutation. 5 and 3. So I'm going to press 5. Let's zoom out just a little bit. 5. Then I'm going to go second because I want my green option. So second, the number 9, and then I'm going to hit 3. And I get 60. So you can do it on your calculator as well. Okay? All right, our next example. Let's going to be this one. Okay. An art gallery has 9 fine art photographs from an artist and will display 4 from left to right along a wall. So does order matter? Yes, because they are displaying it from left to right. So this word right here, display, I know order matters, okay? Now, I know it's a permutation because order matters. How many total photographs are there? There are 9. How many are we choosing? We are choosing 4, okay? So we can do this in our calculator. Our calculator on. We can do 9, okay, that's my n, and then second permutation, and then 4, and I get 3,024, okay? That's the fast, easy way. The other way is 9 factorial over 9 minus 4 factorial, and then you can just line them up. So 9 factorial over 5 factorial. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, and I'll put it right under 5, 4, 3, 2, 1. So all of these just divide out to be 1. 5 divided by 5 is 1. 4 divided by 4 is 1. 3 divided by 3 is 1. 2 divided by 2 is 1. 1 divided by 1 is 1. So I'm really only left with 9 times 8 times 7 times 6. And if you put that in your calculator, you will get the same answer. Okay? All right, so that is our first day of probability and permutations. And I will post your homework, guys. Thanks.